Good morning, this is C. Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. So today I am going to discuss about different case of Q of x. F of d into y equal to Q of x is a differential equation where f of d is a operator form and Q of x is function of x. In the last sessions we have discussed what is yc and what is yp and what is the general solution of the differential equation with constant coefficients and all we have discussed. Now today we are going to discuss about general solution of the differential equation where Q of x equal to combination of exponential into some another function. So here the general solution of f of d into y equal to Q of x where Q of x is here e power x into v, where v is a function of x. What is v and what is function of x? So in this method and in this chapter we have v nothing but sin ax or cos ax or x power k. Only we have three cases where v is sin ax, cos ax or x power k. Already we have discussed individually how we can find particular solution where Q of x equal to sin or cos or x power k. Now in this case Q of x is combination of exponential term into v. V is either anything sin ax, cos ax or x power k. Now k is a constant, a also here constant. In this exponential e power a, this a is different and in this sin or cos, this a is different. So we have to remember which one is a and which one is sin ax or cos ax a. And how we can find the general solution of f of d into y equal to Q of x. So nothing but y equal to yc plus yp. That is complementary function is yc and the particular integral is yp. What is a complementary function and how we can find? Based on the roots, we will find complementary function. And how we can find yp? Yp based on Q of x. Here we have in the RHS term Q of x. The Q of x is mainly function of x. This function is either anything sin, cos, exponential, x power k. In the last methods we have discussed individually how we can find yp where Q of x is exponential or sin or cos or x power k. Now in this case we have Q of x is exponential term into v. V nothing but sin ax or cos ax. So here a is different and in this exponential a is different. We should remember that one. Now go for the method. Particular integral of f of d into y equal to Q of x where Q of x equal to e power x into v. V nothing but sin ax or cos ax or x power k. Based on the problem we have anything either sometimes sin, sometimes x power k. And how we can find this solution? We have to check. So first write the particular integral. And what is the particular integral? 1 by f of d into Q of x. This is standard form and this is general formula for any Q of x or for any method. So Q of x in this case e power x into v and f of d is nothing but operator form of the given differential equation. The operator form of the given differential equation is f of d and Q of x is in this case e power x into v. This is a combination of two functions. E power x is a function, v also a function of any one of these cases sin, cos, x power k. Now how we can find the solution? Individually we know the solution. If it is e power x specially, just to replace in place of d equal to a. If it is sin, we have to replace d square equal to minus a square. If it is x power k, we consider f of d as 1 plus or minus phi of d whole inverse form. So now in this case we have combinations of two functions. E power x is a function, v also a function. So what is the case and how we can find, which is also very simple form and very simple method. When we have combination of exponential into anything, just simply remember, first take x quotient is here a. In place of d, replace d plus a. A is nothing but here e power x. X quotient is nothing but a. So write e power x left hand side and replace whatever d in the denominator. Replace d as d plus a. So nothing but 1 by f of d plus a into v. We don't know, v which is either any one of the form, sin ax form, cos ax form or x power k form. But mainly we have one thing, that is nothing but exponential term is there and another term is there. So whatever exponential term and whatever a there, replace in place of d equal to d plus a. So now take the e power term left hand side and 1 by d plus a into v is actual function now. Now this e power ax part is completed. Just replace in place of d equal to d plus a and write in the left hand side and keep aside, and now solve for 1 by f of d plus a into v term. V is either sine, cos or x power k. Now we have to evaluate 1 by f of d plus a into v, which is depending upon the v term. V is either sine, cos or x power k. Now which is here we have one problem, that is d cube minus 7d square plus 14d minus 8 into y equal to e power x into cos 2x. Now which is very simple form, which is f of the form f of d into y equal to q of x, but here the q of x is here e power x into v form. What is x and what is x quotient here? 2, 1. X quotient is here 1 and cos x in this is 2. We have to remember, first thing you have to replace in place of d equal to d plus a, then that exponential part is completed. Then write exponential term in the left hand side and solve for 1 by f of d plus a into v. And what is v here? Cos 2x. And before that, this is of the form f of d into y equal to q of x. What is the solution of this f of d into y equal to q of x? Y equal to yc plus yp. So in any case or any method, we have the general solution is y equal to yc plus yp. Yc is nothing but complementary function, yp is nothing but particular integral. Complementary function we can find by using roots and the particular integral we find by using q of x. So first write the operator form. So in this problem the given is operator form. Now write the auxiliary equation. What is the auxiliary equation? In terms of write m. Whatever d and in place of d replace m, that will give f of m equal to 0. That is the auxiliary equation. What is the auxiliary equation in this case? M cube minus 7m square plus 14m minus 8 equal to 0, which is a polynomial equation of order 3. And how we can find this polynomial equation? By using synthetic division. First, we have to take one root. If we substitute the root in that polynomial, we'll get 0. Then the value is said to be root of that polynomial. So here we got 1, 2, 4 are the roots. How we can find these roots? Synthetic division. What is the synthetic division? Take the coefficients of the given polynomial. That is 1, minus 7, 14 and minus 8. And if suppose 1, 2, 4 are the roots, so I am taking 1. 1 root means if we take 1 in that polynomial, that will become 0. 1 minus 7 become minus 6. Minus 6 plus 14 is 8. Plus 8 minus 8 become 0. So if we randomly we have to select one root and then by using synthetic division we can find remaining 2 roots. So if we substitute 1 in that polynomial, we'll get 0. So that's why I'm taking 1 is here. So 1 plus 0 is 1. 1 ones are 1, minus 6. Minus 6 into 1, minus 6, 8. 8 ones are 8, 0. 1 already we know the root, and the remaining roots we find minus 6n plus 8 equal to 0. If it is a second degree or quadratic polynomial, we can find roots very simple. 8 ones are 8 or 4 twos are 8. 2 plus 4 becomes 6. Like that, we'll get the remaining 2 roots. So the factors are here m minus 1, and from this we'll get 2 fractions. One is m minus 2 and m minus 4. These 2 roots and one more root is m minus 1. So m minus 1, m minus 2, m minus 4. These are the 3 fractions or factors. But take that equal to 0, we'll get the roots. The roots are here 1, 2, 4. So here the 3 roots are real and distinct. So what are real? 1, 2, 4. There is no complex value. So that's why these 3 are real roots, and which are distinct roots. How we can write complementary function if roots are distinct? Complementary function equal to c1 e power x plus c2 e power 2x plus c3 e power 4x. If roots are distinct, we can write separately c1 e power x plus c2 e power 2x plus c3 e power 4x, which is a complementary function, or simply we write this yc. Yc we indicate that complementary function. And next we have to find particular integral. What is a particular integral? Based on q of x, we'll find particular integral. What is q of x here? E power x into cos 2x. The formula of particular integral is particular integral equal to 1 by f of d into q of x. For any method, already we have discussed the particular integral is 1 by f of d into q of x. F of d is nothing but operator form of the given differential equation, and q of x is e power x into v form. In this case, what is q of x? E power x into cos 2x. So f of d write in the denominator 1 by f of d into q of x form, and q of x is e power x into cos 2x. Now what is the first step to get particular integral? The first step is substitute in place of d plus a. What is a here? 1. Consider only e power ax. X quotient is here 1. Now replace in place of d plus a. A nothing but 1. So take d equal to d plus a, that is d plus 1. So e power x left hand side, and replace whatever d and wherever d in place of d, just to take d plus 1. So 1 by what is d? D cube. D cube is nothing but here d plus 1 whole cube minus 7 into d square is nothing but d plus 1 whole square. Next plus 14d. 14 into again d. Replace d as d plus 1. 14 into d plus 1. Next is minus 8. So e power x term is completed. So take e power x left hand side and replace d equal to d plus 1. And take left hand side, and no need to disturb this exponential term. Now simplify the denominator term. What is the denominator? D plus 1 whole cube minus 7 into d plus 1 whole square plus 14 into d plus 1 minus 8. Everyone know the formula, a plus b whole cube, a plus b whole square. Just apply a plus b whole cube formula and a plus b whole square formula. Then simplify that, you will get one more function, that is d cube minus 4d square plus 3d. The given f of d is different. Now after replacing d as d plus 1, we get another function phi of d, or another function f of d. D cube minus 4d square plus 3d into one more function, that is cos 2x, which is nothing but v. E power x into v. E power x term is completed. Take left hand side and replace wherever d plus 1, and simplify using the algebraic formulas. A plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. And a plus b whole square is nothing but a square plus b square plus 2ab. Apply the formula and simplify. D cube terms are right one side, d square terms, d terms and constant term. Then you will get another function or another form of f of d. That is d cube minus 4d square plus 3d into cos 2x. Already we know where q of x is either cos or sine, just we replace in place of d square equal to minus a square. In this case, a is nothing but 2. Minus a square is nothing but minus 4. Now replace d square as minus 4 in this denominator. D cube nothing but d square into d we can write. Write d square into d. D square is nothing but minus 4 into d as it is. So minus 4d plus d square is nothing but minus 4 again minus plus 16 plus 3d as it is. We cannot disturb d term. So d is as it is. Wherever d square in that place only we replace minus a square nothing but minus 4. So minus 4d plus 3d plus 16 into cos 2x after replacing d square equal to minus 4. So then we'll get e power x into 1 by, after simplifying we'll get 1 by 16 minus d into cos 2x. D as it is there only and constant terms to simplify, then you will get e power x into 1 by 16 minus d into cos 2x. Now here the denominator having d. What is the next step? We have to change d into d square by taking rationalizing factor. What is the rationalizing factor of 16 minus d? 16 plus g. So multiply and divide with 16 plus g. So if we take multiplication and division with 16 plus d in the denominator having a plus b into a minus b form. So already we know a plus b into a minus b is a square minus b square. That is nothing but 256. A square minus b square is nothing but d square. Numerator is same. We cannot disturb that one. 16 plus d as it is. So e power x as it is. I am writing from starting onwards e power x as it is. So numerator is 16 plus d divided by 256 minus. We change d into d square here. D square again minus 4. Substitute d square as minus a square. Nothing but minus 4. So if we take d square as minus 4, e power x into 16 plus d by 256 minus of minus 4 into cos 2x. Whether sine or cos, we have only one thing. Replace anywhere or any time d square as minus a square. So after simplification here we got only d. So we cannot replace in place of d as it is minus 4. We have to change the d into d square by taking rationalizing factor. The rationalizing factor is here 16 plus d by 16 plus g. Multiply, divide with 16 plus g. In the denominator is same. We have a plus b into a minus b. So a square minus b square form. Now e power x by denominator is 256 plus 4 260. And numerator is here we have 16 plus g. 16 plus d into what? Cos 2x. So multiply 16 into cos 2x is 16 cos 2x. And differentiation of cos 2x is minus sin 2x into 2. Differentiation of cos 2x is nothing but minus 2 sin 2x. Differentiation of cos only minus sin. Here we have differentiation of cos 2x, nothing but minus 2 sin 2x. So we have e power x by 260 into 16 cos 2x minus 2 into sin 2x. So take 2 common in this, we get 2 into e power x by 260 into 16 cos 2x minus 2 sin 2x. 2 common, after common we have sin 2x only. So 18 cos 2x minus sin 2x. So division, take 2 ones 2 130s. So e power x by 130 into 8 cos 2x minus sin 2x, which is after simplification we have particular integral. So individually, which is not a solution. What is our general solution? The general solution is y equal to yc plus yp. Y equal to yc is nothing but c1 e power x plus c2 e power 2x plus c3 e power 4x. Based on the roots, we find this is completely up to here complementary function. And what is the particular integral? That is e power x by 130 into 8 cos 2x minus sin 2x. So this is particular integral e power x by 130 into 8 cos 2x minus sin 2x. This is the particular integral. Add both the terms yc term and yp term. The combination of yc plus yp is nothing but general solution, which we indicate y. Y is nothing but complete solution of the given differential equation of the form f of d into y equal to q of x. Here q of x is e power ax into v form, combination of two functions, exponential function and another function is v. V is either anything, either sine, cos, x power k or anything. Hope you are all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.